In this video, I'm going to teach you about the chi-squared test for goodness of fit. This test is used to compare two distributions of a categorical variable. Specifically, it compares the expected values of the data in a sample to the actual data gathered in the sample. To compare these two distributions of values, we must first start by declaring our hypotheses. Our null hypothesis will state that the expected distribution will match the true distribution. Our alternative hypothesis will state that the expected distribution is incorrect in estimating the true distribution for at least one category. Once we have stated this, we need to check if the sample data meets the necessary conditions before we perform the rest of the test. These conditions are that the sample must contain data from a well-designed random sample or randomized experiment, and that all expected counts for the distribution are at least 5. As a part of the random condition, if the sample is conducted without replacement, you must ensure that it contains less than 10% of the total population. Next, to measure the degree to which the distributions differ, we must use the chi-squared statistic. This statistic is calculated by adding up the squared difference between the observed counts and expected counts of each category divided by the expected count for that category, given by this equation. We use this statistic to analyze the density curve of the chi-squared distribution. These curves have only non-negative values and are skewed to the right. The number of degrees of freedom for these curves is equal to the number of categories of the sample minus 1. When we find the p-value in this test, we are looking at the area under the curve beyond our calculated chi-squared statistic. If the test finds a statistically significant result in the conclusion, we should do a follow-up analysis. In this analysis, we identify the primary contributors to the chi-squared statistic, since it is in these categories that the difference between the observed and expected counts is the most significant. Now it's time to try it on a problem. Pause the video and read the question before we go over the answer. Since the question calls for a comparison between the gathered data and the expected data distributions, we can identify this problem as needing a chi-squared test for goodness of fit. Now it's time to state our hypotheses. Our null hypothesis states that the birthdays of all NHL players are evenly distributed across the 4 quarters of the year. Our alternative hypothesis states that the birthdays of all NHL players are not evenly distributed across the 4 quarters of the year. Now it's time to check to see if this sample meets the necessary conditions. Since the data comes from a random sample of players, it meets the random condition. Since we are sampling without replacement, and 80 players is less than 10% of the total number of NHL players, it meets the 10% condition. It meets the large counts condition, since the expected counts are all greater than 5. These expected counts were calculated by multiplying the expected proportion of players in each category by the number of players in the sample. Now it's time to calculate our test statistic. We use this equation to calculate the component for each category. We add these components to get our chi-squared statistic of 11.2. With a statistic of 11.2 and 3 degrees of freedom, we plug this information into our calculator using the TI-84 to get a p-value of approximately 0.011. Since a p-value of 0.011 is less than the alpha significance level of 0.05, we reject the null hypothesis, since this sample provides convincing evidence that the birthdays of NHL players are not evenly distributed throughout the year. In our follow-up analysis, the sample data revealed that the proportion of NHL players born between October and December was much smaller than expected, and the proportion of NHL players between January and March was much larger than expected. We will go over how to use the TI-84 for this problem at the end of the video. To conduct a chi-squared test for goodness of fit on the TI-84 Plus Silver Edition, turn on your calculator, press Stat, enter Edit. Input your observed counts in List 1 and your expected counts into List 2. Press Stat again. Navigate to Tests using the arrow keys. Scroll down in Tests until you reach chi-squared test for goodness of fit. Press Enter. Make sure that your observed list and expected list matches the ones that you inputted in Edit. Make sure you have the appropriate number of degrees of freedom. Scroll down to Calculate. Press Enter. And that's it.